Hello, everyone. Nope, I'm not live, am I? Try this. Hello, am I live? YouTube's telling me I'm not live. It says I'm live, then it says it's waiting for Tangent Stream. Okay. Oh, there we go. Okay, something's on the screen, so I believe now that we are live. Hello, and welcome to the Tangent Stream, or whatever this is called. You can see I've got some stuff on the screen here. I drew all this kind of by hand earlier today. These are logical diagrams. So right here, this is an abstract syntax tree. So you got three variables, A, B, and C, x0, x1, x2. So this is x0 and these two XORed together. That's a symbol for XOR, not equal. That's a symbol for and so that's the tree. So I'm able to make these little graphs by hand using the graph tool, which I'll show in a second. And I can draw this graph, which is the fully expanded binary decision tree. So if you take this graph or this expression and you replace, you make you make two copies of it for x0, then you make two copies of that for x1, and make two copies of that for x2, and then you simplify everything, you'd wind up with this tree. Or another way to think about it is x0 is this pattern right here. Off on, off on, off on, off on. X1 is this pattern, 0, 0, 1, 1, 0, 0, 1, 1. And then X2 is this pattern, false, 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 true, 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 true. And if you XOR those two together, well, this acts like a mask, so it's only going to be true when X0 is true. So it's only going to be true in this column, this column, this column, or this column. And then you have to say, well, we also need these two to be different. So this column, these are the same. This column, they're different, so there you go. And then this column, they're different, so there you go. And this column, they're the same, so these are the only two places where they're true. So that's the truth table, and you can get it any number of ways. So I want to make some. I've had in mind, I write some software in Rust that deals with this kind of structure, although at scale, with hundreds of variables. And I wanted to do something with it that would, I often want to animate these things. So the idea was that I would use this drawing tool that I make, or this animation tool that I'm making, to make these animations. So unfortunately, this was very, very cumbersome to create. So let's try this again. I'm gonna make a new page here, and I'm just gonna go, and we'll make a Pharaoh. So we'll say this is called the Vex Sketch Tool, Sketch App. Sorry. An app is a container for tools and shapes, and we say new. And if I hit Control G, I will be able to run it. And it knows to put this color canvas on here. And I will make this live. So, the problem I'm dealing with now is that I've made this thing, and I can pretty much make any of the tools that I want. So to reconstruct that graph, I think it was x0, and then x1, and I had x2. So I had three variables. And then you want to put an XOR in between them. So that's ugly. I guess that does not account for zooming, but if you, it knows where the right place is. So I put my mouse over that thing, it'll actually snap to that. And if I weren't zoomed in, that would look right. So I guess I'll have to adjust that. I got a little bug there. And the same thing with and then I can draw this line right here and go there. Very, very clunky in terms of the user interface, not just because of these bugs, but because of like how tedious it is to like go up here to this drop down and pick the symbol that you want to draw. But you can draw whatever you want. You can't actually save it yet, but you can draw. All right. So then, if you want to say, if you wanted to draw the binary decision diagram, I'm not going to draw the whole thing because it's very, very painful. But you click the graph tool, you click up here, and then now you're going to branch on x1, and you're going to branch on x1 again over here because you're branching. And then with x2, you would branch on 4 copies of that. And then with, then you would have a, I don't know if you saw that, but they're somehow managed to get, I think these have an edge going to themselves. So those, I clicked and dragged a little tiny bit while I was doing it, and it dragged out an arrow and attached it to the thing I was looking at. So O is the symbol in Bex for true, or for false, because it looks like a 0. And I is the symbol for true or 1. All right. So now if I want to line these up, I have to do some really bizarre things. There's a nice tool. So look at how these are arranged. And if I hit distribute H, distribute horizontally, it'll make a nice, it'll like evenly space them out, but it will rearrange the order. It goes from back to front rather than from left to right. So if I do that, see, they rearranged. So one thing I want is to be able to take whatever I have here and have a button that clicks. You click on this, and you would be able to toggle it. So if actually, yeah, well, okay, well, that's not actually possible right now because they're created at like runtime, or it's not a. I'd have to do some tweaking to get that to change the way it works. It shouldn't be that hard, actually. Actually, I think if I say this, and if I say, so selection do O, let's do this. I want to change that. So let's turn all of these into false. Selection. What I was doing before is I would take all these and I would just say, okay, oops, sorry. I take all of them, and I'd say send to back, or send to front, bring to front, and take these ones and say bring to front, and these ones and bring to front, and this works. And if I do this, then I don't have to worry about the way it's very clunky. Right? This is a hack, a complete kludge, right? But it will work. And now if I distribute H, then everything stays in the same order. And if I now say align tops, then they're arranged nicely. But they're not arranged. I can't control what the spacing is. I think it would be easy to like sort by the X position, right? And then distribute H. So I could automate both of those tasks there. But I also think I can do this. I think I can say, so this is like each. So each object, selection do O, and I think you can say for symbol. Nope. All right, so in that case, that's not, doesn't like that. So this is a Bex shape. And if I hit Control B on this, I can browse that class and it will tell me what, oh, it's just 4. All right, so for symbol, and that is on the class. But if I change this to an, if I change this to an instance variable, so I move that to the instance side. And then I say, for on the class side is going to be everything that's in here. For a symbol. And then we say, oh, there's new settings for a symbol. And then return self new for, we'll even call it for symbol. Or should I just say symbol? Yeah, I'm going to say symbol. And then, because I want to track the symbol. And then, I don't even need this. This would be at the in that instance for symbol, a symbol. All right, so now we move that to the class side. So now the class side is this. It's going to call this thing on the instance side. And we're going to call this symbol. So we'll rename this. Yeah, it did. I hit Control R to rename it. And we'll say symbol. Oh, it's not liking that. Okay, just liking that. It's fine. Symbol is okay. Yes. It work. It's very slow. Shouldn't be that slow. Oh, okay, there we go. All right, so this should be self-class settings for symbol. And then we just say, what is happening there? Some garbage. And then we just, okay. All right, and we can even just say self here. So basically, we're just moving all this logic, and we're doing it on the current instance. And shadow sim, okay. So a symbol. Self settings for a symbol, but it's not self settings, it's self class settings for. And we save this, and probably we actually want to say if there's an instance variable called sim, then we're going to say sim equals a symbol. And probably this should be called like rebuild or something, but I'm just going to save this for now. And I think, all right, first of all, let's just try making a new thing. If I make a, okay, so I did that little clicky thing again. That's wrong. Okay, so the point of that was now if I have the selection, and if I say O symbol, and if I say like X0, they should all change to X0s, or these two should change to X0. And if I run that, they do. Oh, but they, So we want to say remove children. And I think you actually have to do this again, but if we say like and now, then those should change to ands. They did. Okay. Oh, so it picked up the good. Okay, so it picked up the. I'm not sure what the rule is because sometimes I have to like make new symbols, or I have to make new objects for it to pick up the method that I add, and sometimes it just works. I'm not sure what the difference is. Okay, so now we can change these to anything we want. One. So the thought would be to take this and change this to have this trigger that same behavior. So this is in a class. Well, we don't have to know what class is because we hit this inspect button. Now we hit this browse class button, and we get Bex SketchUp, and then we say make UI, make symbol dropdown. This is a mistake. It says that this button is not used, but it actually is. It's used right here. So when the click, we set the button text, and then I think we want to say, I think it knows the selection. Make symbol dropdown. I think. All right, so we say selection. I think we just say this. Selection do. Graph tool symbol O, and then selection do. O symbol X1. But O symbol is O. Right, so each, we'll say each symbol. Each symbol is O. Because O is the one I'm looping through up here somewhere. And then each. And then on, no, we do it like this. What am I thinking? So we're going to do this, we're going to run this, and then on, error do, and then just nothing. So just ignore it. So if it can be converted to a symbol, if there's a selection that can be converted to a symbol, whatever's in that selection, convert it to that symbol. I think that should work. Okay, didn't like that because I have 2 of these maybe. Yes, that was an extra one of those. Extra right bracket. So I think now if I do this, it's not going to pick it up because this has, you know, this had to be, this isn't a class method. This is being constructed. So I have to make a whole new version of this sketch app. Yeah, it did nothing. All right, so we go all the way back over here on the left-hand side. And we're going to click, I see people are watching. Hello, welcome. If you have questions, ask them in the chat. I'll respond as soon as I can. And then I'm going to click this button. I have a new version of this now. So if let's make some x zeros. And we select them all, and let's turn them all into false. Yes, it worked. Okay. All right, so now that's a much better way to make a truth table. So we'll say align bottoms. At some point, I'm going to make icons for all these things. I know you can't see them because my head's in the way, but there's little buttons here, and they're just the names of methods that you can call. And almost all of them, I wrote these by writing some little piece of code in the bar down here, or in the little, what do you call it, REPL thing down here, and then just pasting that into, I guess the selection. I think the selection object knows how to do all this stuff. All right, so great. Now, if I wanted to make that a truth table, it's still not like lined up the way they should be. Really, we should have a method called like row, right? So like, really what we want is something similar to distribute H, but make a row. So like, make row would be like selection do. Can we say sort by? First of all, selection. Okay, so print that selection, sort by. Can we do sort by? No, sort. Yes, there. I know there. You can say sort by somehow. Selection doesn't have a sort by because it's not. Okay, so selection copy sort by. That should selection copy should give me a. Oh. That should clone it. And now we have an array. I know this works out. Sort. I should just inspect the selection, right? Selection, and then browse the class. Oh, I can't. Control G to, okay. Being stupid. So if I look on the meta here, GS selection is a subclass of order collection. So it should allow me to sort. Why can't I do that? Enumerating, first do, copying, collection, sorting. Oh, so just sort. And then sorted means a copy of it, right? So sort and then sort by a sort block. Okay. So AB and then less than or equal to. Okay. So I believe we can say, so we should be able to say selection sort. I was saying sort by, that's why I didn't. So we have A and B, and we say A GS position X less than or equal to B GS position X. And that's, we'll sort them left to right. And then we can even just say sorted. And then it doesn't matter if we sort them in place or not. That makes no difference. So then, because then we can do a cascade. So then the cascade is you send them, you mutate that object in place, and then you send it a new message to do something else. And then we want to say do. I don't want. I want. What am I trying to do? I'm trying to make a row, so I'm going to start at the left, wherever that position is right here. I want to get the position, and I want to get the width, and I want to accumulate something. So that's inject, right? Inject. Selection sort. Pretty sure it's called inject. But maybe it takes another parameter. All right, so let's browse references to this. I'm not. Ooh, it's not called inject. It's called inject. Something, but it's inject with something. Inject into. That's it. So, so we inject. We want to start with. All right, so selections. So we're going to sort it. Selection first. All right, so we'll say x0, not x0 from my land, from logical land, but x0 is in the first x coordinate, or we'll call it left. Left equals selection first GS position X. And then selection inject left. All right, start with left. And then into. And then we're going to say O, and then the like accumulator thing, right? The object is going to be OGS position X. No. We're going to say, oh, we're going to move that to the leftmost point. So GS left is the accumulator. And now, so we move the, we grab it by the left-hand side, drag it to that spot, and then A how does this work? You give it, you return the accumulation? Yeah, the next value, okay. Sum and each, okay, so it's A and then O. The accumulator, and then the object. And then, so then the next accumulator is going to be A plus O width. But also we want like them all to be lined up on the top. So selection first, GS position. So well, start. And then left equals start X. And then now we're going to just line them all up next to each other one at a time. So not even just GS left, but GS position is going to be, the X coordinate is going to be A, and then start Y. And then they should all line up. And if I run that, I expect them to be just a flat row. And I'm going to do this so that we can, oh, right, that doesn't work yet. But does it work yet? We never tested that. It does work, okay. So if I run this and then I hit this button, I expect them to all be in a row. But instead, did not understand X because I already put the X here. Start is selection for, I think these are mad because, yeah, that worked. Okay. So now I can make a row. And let's put this, I don't actually remember what class has all these things in it, but let's find it. So if we say distribute H, distribute H was actually contributed to me. That was my first contribution to an external person. So thank you for that. And if I say yeah, Control M for browse implementers, and it's in GS selection. What was that? Oh, add filter. So if I believe if I just change this, all right. So it looks like inside of GS selection, you create a method with some name. So we're going to call it make row, and we're going to save this. So make a row horizontally. Then everywhere it says selection, we will say self here. So make a row horizontally. That's spelled right? Yeah. So then we need a selection. No, selection is self. Selection. So every time I see that, can I just rename it? No, I can't rename it because it's not well formed yet. So we say self, but we need a start. So start. We need a left. And this is a self. Inject into GS position start Y, goes with. And period and self update bounds. And I think we say check mark. And now, right, that was because it was distribute H. Now if I say make row, I believe if I make another one of these, we should have a button over here that says make row. We do. So now if we have a bunch of random things. All right, so I gotta, I want to hook up the delete button, the delete keyboard button to that thing here. I imagine if I do this with make row thing with that line selected, it's going to blow up. But let's try it. Oh, it didn't. Okay. All right, because lines ignore the positioning commands. That's kind of nice. All right, so if I say all of these and I say make row, they should make a row. Why do they make it up there? Something went wrong. It didn't do that in that first demo. So okay, so now we can say GS selection new make row, and we can see that method. Left equals start X, start Y. Oh, because it's because of this thing. That's what's throwing it off. So I need a better way to filter those out. If I do make row now, whatever one is the leftmost. I don't know which one is the leftmost. Oh, wait, there's okay. Wait, it's going to sort by the position. You see the arrows ignore all the positioning stuff, and so they return a default value saying they're at 0, 0, and that's why that's why it goes to 0, because they were at the leftmost. Okay, so now if I say make row here, that I would expect it to come out of this one. And let's make this like, let's mark this as being something other than the x0. And if I say make row, boom. Okay, yeah, that worked. Self-update bounds is also meant to trigger some kind of it's supposed to trigger a redraw of the thing. I'll worry about that another time. Okay, so the point of that was now I can say I can draw anything. I can draw any number of, oops, I use the graph tool. 1, 2, 3, 4, 5, 6, 7, 8, 9 because I made one with an arrow. I really gotta get rid of that because that's really annoying. But I do that and I say make row. Now I have my little truth table, and they should be sorted. I would think this one is, yeah, this one is behind everything. This one is behind everything. This one is on top of everything. Yeah, because it sorts them. Okay, so that's really nice. No, that I'm fooling myself. That shouldn't happen. So now this one is on top. Wait, I'll make that a different color. This one is on top of everything. And when I sort it, it's going to be on the left, and it's still going to be on top of everything. Okay, it does not change that. It did not do the left-right thing. Okay, so I was foolish to say that. Okay, so we make a row that all lines up nice, because that's how I want like a truth table to appear. And I was thinking earlier about making an object that just represents a truth table, which would be an array of bits, right? Or an array of 2 to the n bits, where in this case 2 to the third power is 8 bits, right? So this is a truth table for 3 inputs. And then make that like a compound object. But I may do that. I may have a little button up here that does that, and then it would be nice to be able to take that object and just like edit the bitmap like directly in here, rather than picking the ones that I want to be true. Because doing this operation, I have to like get them so that I can select only those ones. Then I guess I can say this now, so I can mark them all as being true, select them, and then make row again. But it would be nice if I could just like edit the compound object here, but also be able to edit the individual objects. And I do have a group command, but it's meant to create a compound object. So not compound object in this. We have groups, and then there would be one that is like actually a named thing in the scene called a sketch. I don't know. Okay. So with the thing selected, right, so I have another problem. So if I say x, so let's say these are all x0, but there's 2 kinds of x0. There's x0 as an input variable, meaning like when we're doing an expression. So if I want to say, like I'm saying this is the visual language I am creating for binary expressions, right? So if I say x0 and x1, right? Oops. That's one kind of x0. Then I want to say if so when it's an input, it's a box. So these are literals in a logical propositional logic. These are literals, true and false, constants, and then these are the literal variable names, or rather they're not. It's this thing right here. So you would assign a variable. Say you have variables A, B, and C. If you wanted to brute force enumerate every possible combination of those things, then you would count in binary. So this is 0, 1. This is the ones place. This is the twos place, and or the fours place. So 0, 1, 0, 1, 0, 1. This is 0, 0, 2, 2, 0, 0, 2, 2, and this is 0, 0, 0, 4, 4, 4, 4. So 1 plus 2 plus 4 is 7. 1 plus 2 is 3 plus 4 is 7. So this is 7 in binary. This is 0 in binary. 1, 2, number 2. 2 plus 1 is 3. 4 plus 0 is 0. 4 plus 0 plus 1 is 5. 4 plus 2 is 6. 4 plus 2 plus 1 is 7. So this is counting in binary from left to right. Might be kind of nice to actually have the numbers in there to illustrate that point, or to be able to generate those numbers. But the point is that you could, if you had variables A, B, and C, or P, Q, and R as they're usually called there, you could assign them to any one of these patterns. I mean, you can assign them to any pattern where they're all where the vectors are linearly, I forget the word, linearly independent, which these are, I believe. I believe that's true statement. Right. They're linearly independent. You can create any pattern of 8 bits by ANDing and XORing these 3 things together, which is why you can put any Boolean expression into algebraic normal form. I find this very hard to explain on the fly, which is why I'm making these tools, because I like to talk about them, and I want better tools for explaining them so I can give like a nice presentation about it. And sometimes I'm just rambling and saying things that are true, but like, I don't know if they mean anything to you people listening, but they mean something to me. But it would be a lot easier if I could demonstrate the thing, the idea. Anyway, the point is A, B, and C could be mapped to any one of these things. Any 3 vectors that are linearly independent could be mapped in different ways, and to those variables. And so you could say this is A and this is B and this is C, or you could say this is A and this is B and C, and so you have like I guess 6 combinations or 6 ways of ordering them. I would think. Yeah, 3 factorial, 3 times 2 times 1. So and so these are not variables, but I call them signals. So this is the input signal corresponding to one of your variables, the input signal corresponding to another variable, and so on. And the signals over time would take this pattern as you brute force try every possible combination. So at step 0, this variable would be assigned to 0, 0, 0, and at step, in this case, so counting 0, 1, 2, 3, 4, 5, 6, 7, 7 would be, they would all be set to 1. And then likewise, these have the same numbering. So that's like the convention that I'm trying to establish, right? Okay. So, right. So the point of that is that sometimes you want to talk about x0 as one of these input signals, in which case it is a literal, a something like a variable, but what I call a signal instead. It is the signal to which the variable is assigned. So your variables go away, or maybe there would be a, oh wow, that's unfortunate. Using select, maybe as you move this around, you would have the variables and you could see which ones are assigned. So it might actually say A, B, and C, and so you could see how they were arranged. Rearranging the variables and mapping them to different signals would be like reordering, can allow you to compress a binary decision diagram. This is fully expanded, so it's completely uncompressed, but you can compress these by following some reduction rules. I'm going to delete that thing. Okay. All right, so if I go back over here, here, this same x2 is being used as a branch. So just the convention is that the inputs into a function, something like a function, these functional nodes are circular, whereas the constant nodes are square. And so when you start treating it as a branch, now you're saying if x2 is true, then follow the high branch, the solid branch. And if it's false, you follow, if it's low, you follow the low branch. If it's 0, you follow the low branch. And so this one right here is a branch it's being used as a branch variable. And the way to read this is this data flows up through this arrow into the node, right? The operator. Whereas here, the convention is the low branch is usually on the left and the high branch is usually on the right. And so you go from the lowest possible value to the highest possible value in this signal space, right? So as you enumerate, the lowest enumeration is over here. It follows all the low branches, and the highest one follows all the high branches. And zero is always x0 is always the one that goes, that has a period of 1, and this one has a period of 2, and this one has a period of 4, and so on. A lot of binary decision diagram packages draw x0 at the top, and I find that to be backwards. It's just been the convention since like the data structure was invented, but you want to maximize collisions, duplication. So every function has a 0th variable, but not everyone has a 10th variable, right? So you want 10 at the top because you want to maximize the number of things that are the same at the bottom. So that's kind of the logic of a binary decision diagram package, which is the thing I'm trying to explain. Okay, so I'm rambling about that, but I mean to be rambling about drawing. All right, so I've got I can make a row now. What do I want to do? Right, so now to do this, if I want to change those all into circles, the way I did that is that they all have a corner radius, so they're just rounded rectangles with the corner radius set to 0. And if I set them to 25, I believe these are 50 by 50, so if I set them to 20, it should be almost rounded. Let's see. Boom. Oh no, they're 40 by 40. So if I set them to 20, then they should be rounded. If I set them to 10, they should be like half rounded rectangles and so on. So 20. Okay. And so then at 20, you get a perfect circle. I guess I'm okay with that. So now I have a thing that really does not belong on a selection, right? So maybe I'm not sure what I do to put that here. It really does not belong on that class because it's not a general purpose drawing tool. I could do something like this up here, where I just take this class. I think this is fine though for now. But one of the things I like about this environment is that I'm working in an IDE, so I can always just fire the REPL and run commands like here that are not part of the user interface yet. I don't need this anymore because now I can I can say this is and. I just did that. I implemented that live here, so that's now done by this. So this can go away. Make row is now part of this right here. That can go away. I hear a baby waking up, so I'm probably going to have to go in just a minute. And maybe this is a good place to stop. I think the other thing I wanted to do, well, I really want to generate this because this is like a standard structure. Like everything that has any truth table of 8 variables is going to have this exact same structure. Whereas these Okay, so the way this should work, the way it works in Bex, is you have a shell, and there's a little stack language. And somewhere over here, I made this. Not that. Hang on a second. I know I'm rambling. Drawing Bex syntax trees. So this is like an old version from like a couple months ago. So to make that, I said Bex and Bex X, Bex XOR. Right, so I can actually take the syntax tree and build it that way. But I think what I want to do I want to take this and I want to make it, first of all, use the new symbols that the visual language that I've made. So I'm using the symbols rather than the words, which I think is easy. I think if I change this and I say X op XOR args, okay, XDef new, was that? XDef. House class. I think there's like an as. Oh, that's weird. I want it down here. GT graph for? No. There's probably a place where I'm building a op art, where I'm building a thing called Bex. Yes, Bex. Okay. It's not an object, so if I say GT drawing for self stencil, all of this needs to be rearranged. Okay, so okay. So when I say XOR, what does it do? Self description XOR takes exactly op XOR. So do I have an op? No. I have a symbol. What do I have in here? Op and args. Okay, so X0 is the args. Color. No, it's geometry. New. So I think anyway, the stencil would just be Bex shape new symbol and then op, self op. Right? Let's do that. I think that works. I haven't looked at this code in a long time, but I think that's going to work. So if I do this now and I rerun this, boom. Oh, don't know how to make a Bex shape for nil. Okay. So right here, it would be telling what the symbol is, and the op is nil. So self is a Bex var. Oh, so in Bex var, we need to do something. So meta, vid color. So if we say stencil here, so V is a variable ID. That's another word from Bex. Okay, so that's a natural number. That should just be a number. Okay. So vid. So we will say stencil is return Bex shape new symbol, and then the symbol is going to be string x plus vid as string, and then the whole thing as symbol, right? So x0, x1, x2, and so on. Cool. Okay. Yeah, same thing. Oh, so we could probably say print string. Self print string as symbol. Okay, and if we do that, then that should go away. And then when we run it again, boom, there we go. Okay, so we have everything working now. The lines are not quite right because they don't use the new syntax, but I'll worry about that later. And the background is not the right color. Right, but the thought was, rather than writing the AST like this, can I say, I think so. You want to make like a little stack thing, right? So like the example that I want to have. Okay, so let's try this. How about let's make a new copy of this page? Can I copy it? No, I can't copy it. How about all of these are now done? So just delete that, and then oh yeah. I contributed a patch to Glamorous Toolkit to allow zooming in these things with your mouse wheel. But zooming is also for scroll, and Tudor really pointed out that you should not use the same thing for both, because if you want to scroll up and down, you will be scrolling your page, and all of a sudden you stop scrolling and you get this zooming in and out, and I'll capture that. So that's on me. If that happens to you in your Lepidor page, you can blame me for that, because I contributed the patch and did not follow his advice. Anyway, so let's go over here. Like syntax trees, drawing binary expressions, and let's just make a new thing. Oh, we'll just add a new page, and we'll call it building Bex ASTs with RPN. All right, so what I'm looking for here is I'm going to give you some notation, right? So what do we call it? Bex shell, maybe? All right, so let's build a arrow snippet, and we're going to say Bex RPN. Let's just say RPN Bex builder. Yeah, I think we'll have a Bex builder. See, it's a shell, but I'm not providing the user interface for a shell, so it's not really a shell. I'm just called Bex RPN. How about RPN build? Bex RPN builder. How about that? RPN is reverse Polish notation. All right, so we're going to say Bex RPN builder new, and create class Bex RPN builder, and it's in package Bex, and tag name RPN. I don't know. Okay, and then we're going to say we're just going to give it a bunch of commands, and then you're going to ask for the top of the stack. So top of stack is a statement at the top of stack. That's going to return stack last. All right, and so we'll create a stack in there, and in RPN builder, we need to add a initialize method, and we're going to say super initialize, even though object doesn't do anything, and then we're going to say that stack is equal to a new ordered actually, is there a stack? Stack new? Yeah, let's do that. All right, so stack new. And that's a member of this, right? Yes, because it's not mad, so it's that, blah, blah, blah. So stack equals stack new. And that was actually was I right? No, it was top, right? Browse class. Yeah, that's top. Okay, so the top of stack is stack top. And so we're going to add some commands. x0. How about we say stack push x0, and then this returns self implicitly. I like that, so we could even say x1 stack push x1. You are going to see a brand new programming language here in just like 10 seconds. Stack push x2, just the symbol x2. Oops, work? No. Oh, I can do it like this. x3, save, and then x4. So there are 5 symbols in this language. We really also want like a list of nodes, right? Because we're not going to do any calculations here. We're going to build nodes. So the stack is just keeping things around to the stack is just keeping things around temporarily while we decide what gets joined to what. So, but as we go, we're going to build these nodes, which are Beck shapes. So we're going to actually add slot nodes here. Boom. Okay. And these probably all should be like one new variable thing. So we'll say we're actually going to create a node. So Beck's shape new symbol x0. And probably this can be refactored, but x1. I'm going to go ahead and remake it. So lit a symbol. Or actually, we should say new, right? New shape, a symbol, because they all take this, right? So stack push, and then Beck shape new symbol, and then a symbol. All right, so maybe we just call this push. Okay, so push a symbol, and then this can just be self push x0. Self push x0. Home. Self push 1. I'm just going to copy this. x2. Boom. x3. x4. And then so we have binary operations, and those are going to be easy. And then there's a unary operation. Unary is going to be, it's not, right? The word not. So I don't have a way to express that right here. Like I can't just say not x4 in this visual language yet. Rather, what we do is that when we are going to add it to a, well, so see, the reason I don't have it is because when you have x4, right? Whoops, not what I wanted. And you're going to branch on things, so these would be all like x, some lower thing, not x4, but x1 or whatever. These are x2. Okay, so you're going to, there's that, and then yep, I had selected. I need a better tooling system. The tools need better state here. Also, I don't know if you noticed, but these keep rearranging in order because they all have the same priority, so you get like a random order every time. That's silly. Destination marker is none, boom. Okay, so now you have this, but if you want to say not x2, the convention is that on this line you put a destination marker is a square. And so it looks like that. Oh, sorry, not a square. You don't use a square, you use a circle. Right, so it looks something like that. And maybe that's a little dark. We can change the fill to something else. I haven't nailed down this color scheme. I haven't nailed it down yet, but something like that. So now that indicates that if x4, then not x2, else x1. So the dot is what indicates the not condition. And I guess you could do the same thing in an AST. And then if you just have this, I don't have a good way to just show not x1 as a freestanding thing. I don't have a method for that. I suppose I could change the background color to something, just change it to like, subtract 2 from everything. 7, 5. What's d minus 2 would be d, c, b. B, and this would be a, and e would be e, d, c. Like that. Maybe that could be, yeah, but that's not distinct enough to be that. Maybe even, maybe something even super small, like 0, 0, 0, 0 RG. So B would be then the last one, 2, 2 or something like that. Like super, super dark. Maybe that could be not, I don't know. Or maybe just draw a little circle on top of it. Don't know. I haven't really decided that. I need to nail that down. I'm going to start making some videos, some little short videos about all this stuff. So I want to have the language like really specified now. I wasn't really planning to use color on that. Oh, and in particular, you don't want to use color because say like maybe you have x3 up here, right? And then x3 is gonna have a line going from x3 to x2, and this to some other thing. So x0, and then this one is going to be the low branch here, and it does not have a triangle. It has none, and it has dash because it's a low branch, and then like that, right? See, but it doesn't have a dot, so you don't do it on the node because the node is shared. And likewise, in an AST, you could have duplication there. I call it an AST as abstract syntax tree, but in practice, it's an abstract syntax DAG. Yeah, so a directed acyclic graph rather than just a tree. So you can have shared nodes. And so that's why you use the dot to indicate a not relationship. The branch itself is the the link relationship itself is the is what tracks the not condition in this language. And likewise in Bex, you have a pointer, you have this thing called a NID. A NID is something like a smart pointer, but it's like an index into an array of nodes, and it has a bit set aside for saying this is negated. So that bit can be floating around. Yeah, whatever. In fact, part of the reason, I say it's a smart pointer, but part of the reason that the numbers go up to 4, x0 to x1, x2, x3, x4, is because those are 5 bits. And with 5 bits, you can make like 4 billion different truth tables and different functions. 4.2, but 2 to the 32nd power. With 5 input bits, you can specify any one of those functions, right? And so you get a 32-bit truth table, and like a NID is a 64-bit thing, and just half of it can be a truth table. So that's 4.2 billion possible functions that you don't have to store as nodes anywhere. So it's a smart pointer to something that is just a made up node, and then the pointer itself contains everything you need to know about the truth table. If that makes any sense. So there actually isn't a node. There isn't a directed graph. It's just a pointer to a virtual node, and a description of what that node would be. And from that pointer, you know everything at the bottom 5 levels of the tree, which is kind of cool. And I think that's something that I don't think any other BDD package does that. All right, so that's backward. Okay, so none. All right, so anyway, so that's why we don't use color for a shared node, but maybe for a freestanding node, we could use a color. But I think probably because the color works with this, because like this is the true and false are color indicated. So maybe that could be that. But I think and also it would be nice to have like a if you're treating it as an input. Oh, actually, that's interesting. See, that's actually very interesting. You don't know what's interesting because I didn't say it. So these are never actually objects. They are always just, as I say, NIDs. So there's a NID that represents x1 and x2, every variable. And that NID is also the truth table that looks like this for up to 5 inputs, right? And then once you deal with a domain that has like 20 inputs or whatever, that truth table just repeats over and over again. So that's why I call it a signal. This signal just repeats forever. But when it's an input, you don't really need a shared node. You could have a shared node, but why? You don't need it. It would just clutter up your graph to have lots of arrows pointing to the same place. You might as well just reuse it, right? Because there's never going to be anything underneath it. And so if it's an input, then maybe you want this to be clickable, and you click on it and it turns black or white, indicating that it's true or false. Maybe there are even 3 shades. So like one would be very close to white, like this. Okay. Let's try that. Oh, don't do that. Graph, boom, and select this, and then turn this into x1. What if we did like that, and we had another one? I'm just kind of brainstorming here. Part of my problem right now is, like, I know I want to make some videos. And I know that I want to have a consistent language between them, but I don't know what that language is yet. The visual language. I'm going to look a lot like this, but there's stuff to tweak. And then I don't know all the things I'm going to do, and so I'm just kind of experimenting, right? So it's kind of a design problem at the moment. So I make a row here. I want to turn this, and we just make this like a very light blue. So we even like CC FF. Maybe even, what is this color? So the middle one is a little higher, so DDFF. Yeah, like that. And then maybe even the fill color could be, I don't have a setting for the text color here. So the text color could be black like this. Nope, the babies are up. Hello, Simi. Okay, they'll go downstairs. I think I'm gonna wrap this up. The babies are up, so you need something? What you need? Closing that. What is that? That's cool. I can't show people what it is because it'd be green on screen. It's a green circle. There you go. Okay, I'm gonna wrap this up. The kids are up, so I'm gonna go. And yeah, I just wanted to share this progress. All right, I'm gonna go.